Are you still wrestling with fragile YAML files, messy Git repos, and ad hoc scripts every time you need to move an ML model from the notebook to production? That terrifying moment when your model works perfectly on your laptop, but when it hits the production cluster, it breaks, it doesn't scale, or worse, it's impossible to reproduce months later. This isn't just a headache, it's a fundamental failure in your MLOps strategy. For years, the data science world has looked to three titans to solve this: Kubeflow, MLflow, and Apache Airflow. Today, in 2025, we are not just comparing features, we are breaking down the entire MLOps philosophy of each tool to determine which one can finally give your enterprise a bulletproof, scalable, and fully automated machine learning pipeline. Stop choosing between speed and stability. Let's find the tool that gives you both. Stick around because the correct answer might not be what you think. I've spent extensive time deploying, managing, and troubleshooting all three of these platforms at scale, not just running a simple local demo. Why is my perspective critical? Because these tools solve fundamentally different problems. Airflow is the venerable workflow orchestrator, a powerful but generalized engine created primarily for ETL tasks. MLflow is the focused champion of experiment tracking and reproducibility, built by Databricks for the data scientist. Finally, Kubeflow is Google's answer to ML on Kubernetes, a massive full-stack platform. Trying to force one tool to do the job of another is where 90% of MLOps projects fail. This review cuts through the marketing hype and focuses purely on production reality, infrastructure complexity, model governance, and most importantly, the end-to-end developer experience for both data scientists and ML engineers. We will determine if your team needs a specialized tool, a general orchestrator, or a full-blown platform. Each of these three tools makes a massive yet distinct promise to your organization. Understanding this core claim is key to choosing your platform and avoiding common pitfalls. Kubeflow's core claim: to deliver end-to-end machine learning native to Kubernetes. It promises scalability, portability across any cloud running K8s, and a full suite of tightly integrated components, from Jupyter notebooks via the central dashboard to hyperparameter tuning with Katib and model serving with Kserve. Its promise is a complete, highly optimized, containerized ecosystem. MLflow's core claim: to ensure total model governance and reproducibility. It promises an environment-agnostic, simple API that makes logging every parameter, metric, and model version a trivial exercise, ensuring that any model run can be reproduced anywhere by anyone. Its focus is on the lifecycle of the ML artifact, not the underlying infrastructure. Airflow's core claim: reliable time-based workflow automation. It promises a mature, extensible platform capable of scheduling and managing complex directed acyclic graphs, or DAGs, making it an ideal choice for the reliable batch processing and data preparation steps that must execute before model training. The core difference lies in their area of specialization. Kubeflow is a complex infrastructure platform. MLflow is a surgical tool for the model artifact, and Airflow is a generic task scheduling engine. No single tool does everything, and the decisions on how to integrate them are where complexity and cost often escalate. Let's move to the technical evidence and specific use case scenarios. Kubeflow is technically superior here. Its pipelines component is custom designed to manage the inputs and outputs of ML components, data artifacts, models, metrics, in a cloud-native way. Kubeflow's ability to scale distributed training, using operators like TFjob or PyTorchJob directly on Kubernetes, is an unrivaled advantage for deep learning at enterprise scale. Airflow, while powerful, requires developers to build complex custom operators, like the Kubernetes pod operator, to achieve the same ML-centric automation, making the MLOps process less seamless. MLflow is the clear and undisputed winner. Its model registry acts as a central hub for version control, stage management, from staging to production, and model packaging. Both Kubeflow and Airflow can call MLflow's API, which is why the hybrid approach is so popular. Without MLflow, achieving robust governance in either of the other platforms is a painful custom engineering task. Kubeflow has a notoriously high learning curve. It demands significant Kubernetes and DevOps expertise for setup and maintenance, making it suitable only for teams with dedicated ML engineers. MLflow has a low learning curve. It is simple to integrate and use, making it perfect for data scientists focused on experimentation. Airflow is moderate. While powerful, mastering its DAGs, operators, and executors takes time, though its community and documentation are vast. The final verdict. The most effective MLOps stack in 2025 is not a single tool, but a hybrid system. If your team is Kubernetes mature, the Kubeflow plus MLflow combination offers the most powerful end-to-end feature set. If your environment is less container-heavy or already runs massive data workflows, the classic Airflow plus MLflow pairing provides a mature, stable orchestrator alongside best-in-class model management. The key takeaway: you need dedicated experiment tracking, MLflow, regardless of your chosen pipeline orchestrator. Choose your orchestrator, Kubeflow for ML native K8s, Airflow for general data jobs, and integrate the governance expert, MLflow, to deliver truly reliable machine learning at scale.